Hello everyone, welcome to our course Azure Kubernetes Services or AKS Deep Dive, which covers in depth a deep dive for AKS and Kubernetes. This video is part of this course and will cover Lesson 3 in Module 2, which is Working with Docker Containers. This video is part of Module 2, Understanding and Working with Docker, and this is where the video is located in the current module. So let's start. Module 2, Lesson 3, Working with Docker Containers. So this lesson will cover, first we will start by the detailed container deployment workflow. In the previous lesson, we have seen a simple container deployment workflow. In this lesson, we will get a comprehensive container deployment workflow so we can cover all the possible steps during the workflow of building and running the container. Then we will get an overview about working with Dockerized application workflow. This will include the life cycle of developing an application on container, including several environments like the testing, pre-production, and production environment, and how the workflow for building, developing, and running containers with a software development life cycle. Then we will introduce what are the stages of Dockerized application, which are build, ship, running. And then based on these stages, we will get more overview about these stages workflow within the software development lifecycle. So how we can map these stages based on the software development lifecycle workflow. After that, we will get an overview about Docker container lifecycle, starting from the perception, including the purge, the walk, the sleep, death, and extensions. So we will get all the possible state in the container lifecycle. Then we will understand developing containerized application workflow. This will give me a very important workflow about developing a containerized application. After that, we will list some of the important Docker CLI commands. So we will introduce these commands with a well description about each command, followed by a detailed description for each command and workflow. For example, we will see the listing all available local images. So we will see the command describing each part of the command and what is the workflow for this command. Then another command, which is pulling an image from the registry. So we will get the details of the command as well as the workflow of the command. Then running containers. So we will get the same, the details of the command and switches and what is the detailed workflow of running a container. The next command is detaching and attaching to containers commands. The one after that is stopping and starting containers, either command and workflow. After that, deleting or removing containers and the images command. Then creating new images from a running container, either commands and workflow. Then executing Docker command for many containers or many images, which means that if I want to stop hundreds of containers, how can I do that with one single command? And then we will get an overview on some of the other Docker commands that you should know about them without getting more details as the previous command. And after that, we will see a complete workflow for building container ASP.NET application to run on containers. All these lessons, we will see all the practical part of this lesson in the coming demos. But this lesson doesn't include demos, as you know the structure of the course. Before we start, let me give you a quick introduction about myself. My name is Mohammed Radwan. I'm a developer technologies MVP and principal DevOps consultant. I have been doing software development for more than 17 years now. Worked on several projects for different enterprise customers across different regions and countries. For more info about me, you can review Lesson 1 in Module 1. So let's look at the comprehensive container deployment workflow. So we will start usually by we have the Docker registry. If you remember in the previous lesson, we explained the Docker registry, which is a place it stores Docker images. So the first step that I have my computer and I will just pull an image from the Docker registry, which means that I will have this image local in my computer. Then I will run this image, which will give me the container. And if you remember, we explained before that the image is a snapshot or a static snapshot read only. And when I run it, it becomes the container in memory. And this will all running in the local Docker instance or the Docker daemon. And as you remember in the previous lesson, I execute this command using the Docker CLI, which communicate with the Docker daemon using the RESTful API. Once I run the container, I can very easily to stop, to start, or restart this container. The same as the virtual machine. Also, I can do any changes on this container, but remember, the container has a state and all these changes will not be exist on the original image. And in order to commit these changes or to have these changes as a permanent, I need to commit these changes, which will create a new image or a new layer with a new image name, and this layer will reference the base image or the previous image because it is hierarchy or depth hierarchy. And with this commit, I can tag my image so I can distinguish between this image and the previous image. And it will be the same workflow, doing some changes and I need these changes as a new image. Then I just commit that with a new tag and so on. Once I commit and I have the new image, I can just push the new image to the registry, which including the new tag, which I can use it later to pull specific image with this tag. And it will be the same commit, adding a new layer with a new image and the new tag, commit, adding new layer, commit, add new layer, and so on. And of course, I can push all the image. So I can have several image which include my application in several versions, and I can distinguish those images using the image tag. Also, I can have the Docker file as we have very quick overview about the Docker file, which include all the instructions to build the image. And I can just run the build command or Docker build command, which will take the Docker file as an input and produce the image as an output and transform each command or each instruction in the Docker file as an image layer. And then I can push that image to the Docker registry. Also, I can save or export the image to the tar, or I can load or import the tar to the image or file. So this is the comprehensive workflow for running a container. So let's understand working with Dockerized application workflow. So as we explained, it starts by the developers will have their own machine and they develop the application or the containerized application on their machine. And on the other side, we have several environments like test, pre-prod, and production. So it will start that developer will pull the image from public registry, let's say Node.js image or ASP.NET Core image. Once they pull the image on their machine, they will start developing the application and load the application on this image. Now they can push this image to a private Docker registry. And from this private Docker registry, they can deploy that to testing environment or pre-production or production. So let's get that in more detail. So what are the three stages of Dockerized application? So Dockerized application has three stages. The first is the build, which is developing an application using Docker container with any language of your tool chain. The next step is to ship your Dockerized application, which means that now you containerized your application, which include all the dependencies like the OS, the runtime, the libraries, the frameworks, and the application. And I can ship that to anywhere. It could be a testing environment, pre-production, production, cloud, virtual machine, physical machine, and this could be several operating systems as we explained before. It could be Windows, it could be Mac OS, it could be even Raspberry Pi. And I'm sure it will work the same without breaking anything. The next step is to run that, and this will run on any platform as we explained, and also I can scale that very easily on thousands of nodes if needed. It could be on the cloud. The scalability will be very quickly with zero downtime. So those are the three main stages for Dockerized application. So let's get more details about these stages in a workflow. We have two parts of the workflow, the developers and the IT operations or the DevOps or site reliability engineers. So what will usually happen that developers will building the containerized application on their machine. Then moving to the next step, which is ship, create or store the images on the Docker registry, and these images including several versions with tags and so on. And the next step is to run this container on the destination, which means deploying these images and run them as a container and even scale that from one nodes or 100 or even thousand of nodes and move that to from pre-production to production using the same images that including my application. Let's look at the steps of each stage. So for the build, the first step is we define the image instruction in a text-based file we called as a Docker file. Then we execute a build command and giving the Docker file to as an input to the build command, which will produce the image. And this usually based on pulling an existing or predefined image that I will put my application. Of course, I can build my image from scratch. And this is a small example of a Docker file. The first line or instruction, it indicates which the image I want to pull from the Docker registry. So as we can see from Node.js latest, if I have this image on my local machine, it will not be pulled from the Docker registry. But here it just indicates which the image I want to use to build my image. The next command or instruction is just to execute this command on this image. Then it will create an image which include this command executed in this image. So if I run a container from this image later, it will just show hello world. So let's look at the steps of the second stage, which is the ship. So the first step, that image shared using registry. So I created my image and I store my image in the registry. The Docker Hub is a public software as a service solutions, which I can store my image in it, or I can have a private registry where I can store the images under or within my company firewall. So private registries can be set up inside firewall and Docker push or pull an image from that storage. Let's look at the steps of the third stage, which is run. The first is container built from the image, as we explained before, runtime representation of the image, self-contained execution environment because it includes everything, the operating system, the framework, the libraries, and my application. So I can very easily, after I pull the image, I can just run Docker run with the image ID or the image name, and then I will have my running container. And of course, I can scale that very easily with thousands of nodes with zero downtime. So let's look at the Docker container lifecycle. So the life of the container starts with the conception. And the conception is all about building the DNA or the blueprint of the container, which is building the image based on a Docker file. The next step is birth, which means that the container will be created. And this will using the run, which create and start the container. The next step is reproduction, which means that commit any changes which will create a new image and run the container from the new image, which include my last changes. Another step is the sleep, where I can kill a running container, or wake, where I can stop the container, or death by deleting stop the container. And the last step is extinction, which mean I can delete the image, which include all the instructions for creating this container. Let's look in more details about developing containerized application workflow. So it starts by the developer, they are developing the application on their PCs. Now they will start by pulling an image, and this image will get from a public registry, which usually is a Docker Hub. Now I have the image, I have my application, So what the developer will do is run the container. So now they have the container in memory from this image and copy the application to the running container. But now I have the running container with a new state, but I don't have an image from that state. So what will usually happen, that developer will create a new image based on that. Of course, in reality, they don't do that manually in this way. They just do that through the Docker file. Once they commit the changes as a new image, now I have the new image on my machine. So now I have two versions of this image. The first image that I pulled from the Docker registry and the new image including my application that reference the previous image. So the next step now is I will push my image to a private registry so I can redistribute this image in anywhere I would like to, which means ship my container. So I can distribute this image to a coworker dev, and then the coworker can just run this image which include this application, or it can be a testing environment, or it could be the cloud. And I will be sure that this image will running the same no matter what the type of the destination, from like machine or Raspberry Pi or device, or from the operating system, Linux, Windows, Mac OS, because it is always running the same. Let's get more details about common Docker CLI. So the first command is Docker version. Using this command, I will get both Docker versions, the client and the server. Docker info. I will get the info about many things like what is the running container, what is the stopped container, what is the paused container, what is the current image, and many other informations. Docker images. This will list all the available local images in my machine. Docker pull. This command will pull an image from the registry. Docker run. This command will run an image to be a container in memory. Docker run name. This will run the container and given the container a name because I can use this name later to stop, start, attach to this container. It is easier than just using the default name, which could be a very long, or using the container ID. Docker BS or process, which will list all the running containers. I can also use the switch A with PS, which means list all, not only the running container, but also the stopped containers. Also Docker start, which I can use to start stop the container. And as we explained before, if I named my container, I can very easily using the name of the container. Otherwise, I need to use the container ID. Docker stop, it will stop a running container using the name or the ID. Docker rm, this will delete or removing the container, because as we will see in the coming slides about the workflow, stop a container, it doesn't remove the container, it just stop it from running in the memory. Docker rmi, this will delete or remove the image completely from your machine. Docker exec, this will execute a command in the container. Just think what is the command you want to execute when the container will run. Docker build, as you expected, this command will use the Docker file as an input to build an image based on that Docker file instructions. Docker commit, this command will be used to commit a new layer as a new image, and this image or layer will reference the previous image. Docker push, this command will push my image to a registry such as Docker Hub or a private registry. Docker attach, this will attach my cursor. This command will attach the current terminal to a specific container. Docker top, this will display the running process of a container if I would like to know what is the running process in a specific container. Docker run help, display help for run command. With the same way I can use help to display the help about top, attach, or any other switches or command for Docker. Let's get more details about each command, either from explanation of each part of the command or the workflow for the command. So we'll start by getting post Docker version, client and server. So when I execute Docker version, the first is the Docker CLI for the Docker client, as we explained before. Then this version switch or command will get both Docker version, client and server. And as you can see, this will display the client version here and the server version here. So when I execute docker info, docker, it is the same docker CLI, and then info switch, I will get all the info about what is the running container, what is the stopped container, the paused container. So as you can see, for example, I have stopped 11 container, paused 0, running 3. I have 14 container. I can see the volumes. I can also see the images, 14 images. I can see the plugins, the volumes, and many other information, listing all the available local images command. So when I execute docker images, it is the same. The images switch will list all the local images on my machine. As you can see, for example, this is the current images I had when I execute this command. And I can see the image or the repository name and the tag, the image ID, and the size. Let's see the workflow of this command, how this command workflow works. It starts as we explained before. On my local machine, I have the Docker client and the Docker server or the Docker daemon. Then the developer will start by executing Docker images command. So what will happen that the Docker client will send this command to the Docker server. So the Docker server, which will actually execute this command, then it will start listing all the local images on my machine. And of course, if I don't have any images, it will display the list without any items. So let's look at pulling an image command. So if I execute docker pull ubuntu, docker is the same part as we explained before. Pull is pulling an image from registry. Ubuntu here is the repo name or the image name. And if you remember what is the difference between repo and image, repo is the collection of images have the same name but using different tags. So what will happen for this command that this will pull the image on my machine. So as we can see that because I didn't use any tag, so Docker will use the latest tag as a default tag. We also can see that pulling this image, it has 3 layers. 1, 2, 3. So this image has 3 layers. And now it is pulled on my local machine. Let's look at pulling an image command with a specific version instead of leaving to or using the default tag. So if I say docker pull ubuntu 14.04, it will be the same. This will pull an image, and here the repo, and here is the tag, which could be name or number. It doesn't have to be number. And as you can see here, this will pull a specific image, which is 14.04, which has only 2 layers, because as you can see, there is one layer already exists on my local machine. It doesn't have to be the latest version because I have several Ubuntu versions on my machine. But what I want to emphasize here that pulling this specific image, it requires 3 layers. One of those layers, it is already on my machine. So pulling this specific image, it just pulled 2 layers only because I have the third one on my machine. So let's look at the workflow for pulling an image. As we explained, we have the Docker client and Docker daemon. Developer will execute Docker pull with the image name. It could be Ubuntu, for example. So the Docker client will send this command to the Docker daemon, and then the Docker daemon will contact the public registry or Docker hub and search for a specific image. Once it has found, then Docker daemon will pull that image and put this image on my local machine. So let's look at running a container as a background command. If I execute docker run with a switch D or detach and specify the image name, Docker is a CLI, run with D is run container as detached mode, which is the default. So if I didn't specify D or switch D, it means that by default it will be D, even if I didn't mention that. And here the repo name. So this is not pulling an image, this is running an image. This is why this command will try to find the Ubuntu on the local machine, and if not, it will pull it from the public registry. Let's see the naming container command. So if I execute docker run name container1 Ubuntu, the run, it is the same. And here I will specify the switch so I can give a specific name or desired name to my container, which will be the container1. And here will be the image name. Let's look at running a container in interactive mode. We have seen running a container in detach mode. Let's see the interactive mode. Docker run it Ubuntu. So this is the CLI, this is the run it, which mean I would like to run the container as an interactive. I can combine it as a one switch, or I can put it in this way. And then this is the image name, which again, it will search locally first. If not, then it will pull it from the registry. And this is the command I want to execute on the container. So my terminal will open the container in this command. Once I did that, it means that I will be running inside the container. So I can detach from the current interactive container. If I press Ctrl P Q, I will detach from the container, so I will not be inside the interactive container. We will see that in more details in the demo. I can also reattach to the interactive container by executing docker attach and specify which container I want to attach to. This is the Docker CLI, this is the attach command, and this is the container name or container ID. Stopping a container command. I can execute docker stop container 1. This is the CLI, this is the stopping running container, and this is the name of the container I would like to stop. I can also start a stop the container by executing docker start container name or container ID. So this is the CLI, this is the start command, and this is the name of the container or the container ID that I would like to start if it is stopped. So let's look at the workflow of running a container. So as we explained before, the developer will execute docker run image name. So the Docker client will send the command to the Docker server or daemon. Now the Docker server will search for this image as it may be exist on the local machine. If it is found, it will create the container. If it is not, then it will search the public registry for this image. Once it found the image, it will pull this image to my local machine and then run this image so I can have a container one running or whatever the name of the container. And once I execute this command again, it means I will have another container with another state from the same image. I can also have other container as well. So let's see if the developer execute docker stop container one. So what will happen now? It will be the same. The Docker client send that command to the Docker server, and then the Docker server will execute this command for container one, which will stop this container. So this container, it is stopped. I can't access it, but it still exists on my machine. It is not deleted. It is just stopped. The same as you stop the virtual machine. Now I can execute docker start container, which will do the same and start my container again. Let's look at deleting removing a container command. Now, if I execute docker rm container 1, this is the CLI, rm to delete or remove the container permanently. And container 1 is the name or the ID of the container. Deleting or removing an image, it will be the same, but not deleting a container, instead deleting an image. So this is the CLI, RMI to delete or remove an image permanently, and Ubuntu is the repo or the image name, and this is the tag either name or version. So let's look at running a container and clean it up automatically. If I want to run container and when it stops, it can be deleted automatically from my machine, because let's say I would like to run container to specific reason, and from this container I will create image, and I don't need this container to be exist on my machine. So what I can do is execute this command. So this is the CLI, this is the run command, and here the RM, which means that auto delete the container if the container stopped. And here to indicate that I would like to run the container as an interactive, and this is the name of the repo, either it is local or it will be pulled from the registry, and here the command I want to execute in the interactive container. Let's look at the workflow of deleting or removing a container workflow. So the developer execute docker rm container1, which is the name of the container. So Docker client will send that to the Docker daemon. And in this case, the Docker daemon will not stop the container. It will completely delete that. Of course, I can't delete a running container. I just need to stop the container first. But here to just give you a simplifying commands. So stop the container first and then execute docker rm container1, and this will completely remove the container from your machine. So you will not be able to retrieve this container again. For creating a new image, if I execute this command, so this is the CLI commit will commit the current changes or state in a new layer to existing image form as a new image. So I will have a new image, which actually is just a new layer that reference the previous image. And this will be the name of the container. And this will be the repo or my image name. And this is the tag, either name or number. So let's look at the workflow of creating a new image. So as we explained before, let's say that I have container 1 and 2 and 3 running. So let's say I started to create some files, do some changes in container 1, and this will send this command to the Docker daemon, and which will execute that on the running container. And now my running container has new changes, has new state with new changes. It could be created new files or copy my application to this container. Now, if I execute docker commit container1 and specify the image name, this will send the command to the Docker daemon, and this will create a new image, which is all about new layer that will be committed to my local machine. And of course, now I have a new image, which is actually just a new layer that reference other layers on my existing machine. And I can just pull that image to my private or public registry. So let's look at listing all running containers command. So if I execute docker ps, this is the CLI, and ps listing all the running container. So this will display only the running container. If I use a ps with a switch, which means all, and this means display all the running and the stopped container as well. With this switch, this will display only the IDs of the container, not all the information of the running container. Of course, I can combine this switch with A as well, so I can display all the IDs of running and stopped container as well. So let's look at stopping or running container command. So if I say docker stop with $sign, which means that stop the coming variable, and in this variable, or it will be like an array, which will include docker psaq, this will include an array that include all the IDs of the running container. So if I have 20 running container, this will be retrieved in this variable, and the stop command will execute or stop all of them. So this is a CLI, this is a stop command, and this command will retrieve only the IDs for running and stopped container. So other Docker CLI commands. What I explained, not all the Docker commands. There is other important commands, for example, load, which load an image from atar or archive, import, create a new file system image from atar bar, port to look up public facing port, and many other commands. So using a Linux-based container ASP.NET development. Let's look at the workflow if I want to build an ASP.NET application. So the first step is to make sure that you install Docker either for Windows or Mac OS or even Ubuntu. So you have to make sure that you have both client and server. Then clone the Git repo of a .NET Core application which exists with a Docker file. The Docker file directs the container to be built. This exists on my repo on GitHub, which is Muhammad Radwan DevOps.NET Docker Git. So if you just copy that, and you will find the link in the video. Once you clone this repo, the next step is that you can edit and build the .NET Core app as your preferences of a choice, like Visual Studio Code or Visual Studio or whatever IDE you prefer, or even a Notepad. Then you containerize the application by building the container image, and you just need to execute this command. We will see all the details in the demos for this lesson. So here, docker build pool, and just give the ASP net app dot, which is, it means the Docker file in the current directory, and this will build the image for you. Now I can just run the container, which include the .NET Core application within the Linux Windows runtime provided by Docker, by using this command, docker run, and here I using rm switch, which delete this container after I stop this container because I don't need it. This is just for demo. And here I will specify the name of the container, which is web, and specify the port and the image name. We will talk more details about Docker networking in the next lessons in this module. And of course, I can stop the container, which docker stop web, because web is the name of the container. Remember, once I stop the container, because I have this switch, which is rm, it means that this container will be deleted. And of course, I can modify the code as required and rerun all the steps again. When I access my browser, I can execute docker start web. Of course, in this case, it will not be available because this application, this container already deleted, but just to give you an idea if you would like to start the container again. And if I navigate to port 8000, I can see the sample.NET Core application running. At the end, I would like to thank you for watching this video. If you have any question or inquiry, don't hesitate to reach out. Thank you.